That's better actually. Okay, welcome back to our final session. So this will be our last session for the day. Once we complete this, we can go back. So it will be a hands-on session. Amit will walk through how to get started with eBPF. I think you heard his previous session overview of Cilium. I think he'll continue the thread from there. Am I right? And show how to get started with eBPF in general and Cilium in particular. Thanks.
Yeah, I'll just take a 10-second thing from a lab perspective. So let's say if you just were to pick up a particular topic, the first thing that you look at is getting started with eBPF. You go click here, and then you can just need to fill up the small form. The moment you click submit, it will redirect you to a particular environment. That environment will be self-created. You don't have to do anything. You just have to click next, next, next. Keep following the pattern. There are some questions that you need to look at. Take care of them. Read through them very carefully. Then there'll be quizzes. The moment you start passing those quizzes, you will be given a badge at the end, and then you can sort of put it across on GitHub, LinkedIn, wherever you feel like. The point is that it is pretty massive in terms of the sort of the feature sets that are there. So you can look at a lot of them. Whatever you feel you want to look at, you can sort of just pick it up, and then you can just go across and subscribe for it, and it will automatically go across and spin up your particular infrastructure. That is one. The other thing is there are a couple of websites. I will share these as well. One is eBPF.io, then there is Cilium.io. I think the best part, which I think a couple of people have asked, that how are things that you are saying are sort of validated or sort of okay. So docs.cilium.io is one repository where the community works fantastically. They put in a lot of effort to update docs, to add new docs with new features that are coming in. There are bugs that they have found, whatever it is. So this is one website that you should probably keep a track of. Now, when it comes down to Cilium, right, like I said, from an open source perspective, I'll talk about the open source side, then I'll jump on the other things. If you want to bring up a particular environment that you want to test Cilium on, right, you can actually run it on Minikube on your particular laptops. You can run it on K3s, CubeAtom. You can run it on any kind of infrastructure that. And the good part is when I'm saying these things, right, all of these are documented as well here. Let's say you want to run on Kind, Minikube, Rancher, whatever it is, you can just run it. So in today's this thing, I'm taking a very small example of Kind. Kind is nothing but Kubernetes in Docker. So this is just a small instance which is running Kind. And okay, now what I've done is, as a preparation beforehand, for this particular cluster, I've just installed some basic things like kubectl, Docker, all that is in place. Now we want to install Cilium on top of it. For installing Cilium, there are two ways. You can either do via Helm, or you can use Cilium's default CLI called Cilium CLI. As a small example, now let's say I type in, it says no, this is not. Now go back to the docs. If you were to look at this, right, it says do this. So that's the thing I'm trying to say, that the docs are very intuitive. So let's just go back here. In the meantime, I'm just grepping for what is happening in the backend for the same VM. What's going to happen? We do Cilium install, and I'll walk you what it's actually doing. So if you see on the left side, right, it says running Kind. It's detected Kind. The CLI has detected that this is a Kind VM, this is a VM that is running Kind. It's using Cilium version 1.5. This is the name, and it says that kubeproxy has been installed. There are ways you can disable it as well. I don't want to get into that right now. But on the other side, if you see, no, let me show you one more thing. Kubectl get nodes. So there are three here, right? So if you see here, it's installed Cilium here on one node, second node, and the third node. And then there is an operator agent. So you're done. You're good to go. So if you were to do kubectl, yeah, this is already there. Sorry, let me just put it like this. So I think somebody had a question, you had a question, right, that what happens from a routing perspective, right? So I had said about either it could be native routing CIDR or it could be VXLAN or Geneve. Now in this sense, it is discovered, auto-discovered that it should be VXLAN. So it's automatically done that for you. It's not that you cannot go and specify it. You can also say that I don't want this to boot up in this mode. You can say that I want this to run in Geneve or in native routing, depending on what values you pass to it. So this all information gets stored in a config map in a Kubernetes map. If you were to look here, right? So this is that config map. So all these values that I showed in that command, they are being punted here. Yeah, sure. One second. Still small? No change, no? 1 second. View, right? Yeah, sorry. View. It's so small, even I can't see. 1 second. Oh, okay. Thank you. Thank you. But still small, no? 1 second. Let me just do it like this. Better. But it will be per session. Okay. Yeah. So this is how you do it in a. This one's still small, right? I think I just edited the windows. I'll have to do it on a per basis session. Where is? Yeah. Now is it okay? Okay. I don't want to actually look at this screen. I'll actually move across to a different this one. So this is how you were bringing up like a local sort of a VM. Now the sort of the topics that we discussed, I want to sort of touch upon them. Let's say you have something like a, let me just show it like this first. It takes BIOS. Yeah, that's fine. Okay. This is. Okay, great. This is running fine. In the meantime, run this. Default, yeah, great. No, not default. This should be, yeah, default. So now I'll just tell what has happened. So in this particular setup, what we've created is, let's just quickly take a look. There are a couple of pods that go by the name of Death Star, X-Wing, and TIE Fighter. Okay, so if you look at the case here, right, what I've actually done from the X-Wing pod, I'm trying to ping Death Star. I'm sorry, sending a curl packet to Death Star. Simple, from pod 1 to pod B. Pod is scheduled on node A, other pod is scheduled on node B. Simple, it's just traffic being sent. Now, what has happened is this guy is actually showing the communication. X-Wing is trying to reach to Death Star. So if you were to look at, let me actually do one thing, kill this. That is actually sending a lot of traffic in the back end. Yeah. This guy is. Yeah, go on. Let's go back in here. Reset it from here and stuff. So I just wanted to show this one. Is this still small? Is this okay? Now? No, this is gone in here, but this needs to be bigger. Right? Fine now? Fine. So if you see this, right? So the verdict is forwarded. So basically it is forwarding. But the key thing that I want to show is identities. It's looking at identities. You see the source labels? See the source. Now, how do you map this? Let's just go here and where was this one? It was right here. Yeah. Endpoints. What is this? Yeah. If you see Death Star, right? Yeah, right here. So it's given it this identity 2403. So if you look here, right, there is no such thing of IPs being talked. It's just about policies that you are looking at. You're looking at endpoints. Let's just quickly do one thing. Now this fellow was able to send traffic, right? This guy, when we were talking of, yeah, multiple IPs. That's right, because that is that's a pod which is being maintained by Azure. That's a metric server. If you see here, that's a very good point. Oops, that was about to go. You see this, right? This is from Azure. So basically, this particular infrastructure is running in Azure. So Azure runs this metric server pod. There is a connectivity pod as well that will be running. Now let's do one thing very quickly. We were able to send traffic, right? We will block this traffic. How will we block this traffic? Very simple. We will just, yeah. Create it. Now if I send, dropped. It just got dropped. Let me just minimize this for 1 second. Oops. Oops. Yeah. And I just want to, that's all that I did. So it got dropped. What else can we do? Yeah, let's just, this is already there. L7 policy. Yeah. Very quickly, I'll show you something about encryption. This is fine. And go here. Okay, great. This is done. So if you see this interface, this is called as Cilium underscore WG0. Let me just quickly walk one more thing. So in case of VXLAN, right, we are creating a VXLAN interface. If it's Geneve, it will be Cilium underscore Geneve. But what I'm trying to talk about is, there is this interface called Cilium underscore WireGuard 0. Basically, I am trying to do pod-to-pod encryption. What I've created here, I will talk about that as well. This is a client pod and this is a server pod. Both are hosted on two different nodes on this particular cluster. The client pod is sending wget packets to the server and it should receive a 200 OK. Now, if I want to see these encrypted packets on the WireGuard interface, right? I don't have to, the script is automatically running. Just give it a couple of seconds. You see, these are packets on WireGuard. These are encrypted on WireGuard. These are being shown on the WireGuard interface. If you see here, right, let me just stop this for a second. Yeah, you see here? It's sent a get, it's got a 200 OK. All these packets are over that particular interface. what else can I show? Yeah. Okay. Yeah, this is one thing which is very sort of interesting. Let's just go back on to X-Wing. Okay. And in the meantime, fire away this. So this is that Hubble CLI. So basically it is printing you everything, what is happening in the network. It's whatever traffic is going through. It's just not your data printer, even your control plane traffic. It's just showing everything. What pod is talking to what it's not doing, what is being forwarded, what is being dropped, everything. There are environments where people, air-gapped environments where people can't open up browsers, right? So you just can't open up browsers. There you can use this. Otherwise, yeah, go ahead. That's a great question. So Hubble is available minus Cilium as well. If you do not want to use Cilium as the CNI, you can use Hubble minus that as well. Similarly for Tetragon, we sell Tetragon, so we sort of support Tetragon from an open source and from an enterprise perspective to go across and work with other CNIs as well. It's, let's say somebody has Calico, they want to use Tetragon, yeah, they can do it. Oh yeah, absolutely. There is not a story. There is a no. You're spot on. There is a story. There is a lab. There is a migration guide. There is an architecture document, and that is something we have I'll just come around. We have extrapolated not just to Calico. We are because, like you said, right? It looks pretty simple when somebody says, "Let's just migrate." Migration is a very tedious ask because let's say you're suddenly moving from IP tables to eBPF mode, right? You've got to migrate and move everything. So everything is taken care of in these particular documents. Nothing. It classically depends on the fact that how you want to do it. Like the way I always do it is blue-green deployment. I would move my infrastructure from node cluster A to cluster B using a blue-green or a canary deployment, move all the traffic there, and then go across and destroy these clusters. Yeah, so Rahul, go ahead.
Did you say that Hubble can be used without Cilium as well?
Yeah, you can use that.
No. How is it possible? Like the identities that are mentioned here, those identities that I coupled Cilium.
I'll be very honest, I have not tried it, but we do support it minus as a standalone way of doing it as well. Tetragon for sure, Tetragon for 100%, because I myself have tried that out. That works out of the box. Minus.
We have integrated Cilium as part of our enterprise solution.
Okay.
So if I can use Hubble with Calico, because
Calico
doesn't support Calico policy, I want to do that.
I can double check you for Hubble, but Tetragon I can give it 100% sure. That because Tetragon we just now went ahead and implemented with an enterprise customer. Hubble I can definitely check back, because if I go back on these docs as well, right, for Hubble, it is clearly says, never tried it, but I can definitely check back. Yeah, I'll check. I will definitely check. Lastly, I wanted to show one more thing, very quick thing was, yeah, about, so let me just minimize, not this. So let me just, yeah, switch the context and go here and kill this for a second, and go here. Yeah, this is the place I want to be in. Perfect. And I want to show you something here. If you see this cluster, kubectl get pod minus a minus. So basically, this is a case of Tetragon. I want to show what is happening from a application, from a couple of applications that are running in this tenant jobs namespace. What are they trying to do? So if you see, I've already exported a log from this particular Tetragon pod, which is doing all this, where all of these are latched onto. Choosing the namespace jobs. Actually, let me just refresh this for 1 second. Bear with me. Export one. So if you see this, right, this is the all the sort of the you are able to figure out what is happening in that particular pod in that particular namespace. It's small for you, right? 1 second. Every single activity that's being done is recorded. Yes. Yes. So service mesh, so you complete your question. Yeah.
Is it a separate component or
It's built in, built in. The only thing is it depends on how you want to implement it, be it ingress or gateway API. So when you talk of service mesh from our side, from Cilium, right, there are two models. Either you go with sidecar or without sidecar. For people who don't know, both options are supported. For people who don't know, when you look at service mesh, there is a concept that you can basically create another, I can say, pods, which can actually take care of your particular traffic in a very laymanish way. But what happens is you create more infrastructure. You create 2 more pods, which will do all the processing for you and whatnot. So we do support, but we have strong sort of proponents of the sidecar-less model. We don't sort of propose that to our customers. We are always of the view that it should be minus the sidecar. So in that we support both, either the ingress or the gateway API. We support gateway API as well, which is Cilium's own gateway API and Cilium ingress as well.
So as a non-sidecar, that becomes a side out for transit.
Yes. Yes. Yeah. So that's a very interesting point that you bring out. So Cilium introduced something called, I'll actually keep that aside. So transit is a different word altogether. We use that word when you have to cater to like a non-Kubernetes workload being able to talk to a Kubernetes workload. That's where we have another sort of a product offering, which is called a Cilium mesh. Basically, you want a non-K8s workload like a data center VM being able to talk to a Kubernetes workload sitting in AWS. That's where we call, so basically in the data center, you will have no Kubernetes. There is no Kubernetes here. So you will run a Cilium agent here, a VM or a container here. That will attract all the traffic, punt it out of the internet. It will go across to AWS, DX router, whatever interface it goes on to, go across and sit on that Kubernetes workload where Cilium agent is running, process the traffic and then send it to that particular workload. So that's a different concept altogether. That's where service mesh doesn't come in. That is called a Cilium mesh. And then there is, sorry, somebody had a question. Yeah. Lastly, I just wanted to show about TLS, and that will be the last thing, then all of us can go home. Yeah. Let me just minimize this for a second. Somewhere here, if I'm not wrong, yeah. So if you see here, right, do you want me to maximize this as well? So I'm trying to send something here. So this guy has detected, so this is basically process events. So from this particular X-Wing pod, right, I'm sending them traffic. So these are all, you know, packets being decoded. It's saying, it's even saying that, you know, what was the cipher you came in with? It's able to print that as well, that granularity. Let's say we just go across and do an open SSL. Boom, it prints that. I mean, that's on the client side, but here it just goes. Now, if you want to see, if you see here, it's just printed that as well. This has come in with 1.2. So you can do that as well.
During installation, there are no prerequisites at all, right? For example, the kernel version.
There are prerequisites.
And is that prerequisites handled by your automatic installation script, or that's different?
That's a great question, actually. So that is something which has come up multiple times, that, you know, if there is, what happens right now is that if the prerequisites are not met, the installation bails out. So we have now taken up as an approach where we need to sort of, even going to the 10th step, don't do that. Bail out at the second step itself. So that the user doesn't get an experience what is happening. Half the time the error codes that people are printing in the open source community are just confuse you big time. So in that sense, it has now come up to the community where community is saying bail out at the second step itself. You print the prerequisites. A lot of things have started happening with, let's say as an example, for IPv6, right? So people are not passing those particular values, or that particular thing is not supported in that region where he's spinning up. So the errors are pointed out. So all of those, so like, let's say you were talking of that, right? So I think if I'm not wrong, prerequisites. Yeah. I think this has gone to a wrong one. This is not these prerequisites. Images, I think there is something here. Kernel requirements or something like that. 1 second, let me just quickly check. There is something, sorry, I might have definitely missed something. I'm not a bit slow on my side. Let me stop some of the traffic. That's also probably killing something. There's no traffic running here. I'll just definitely look up. Sorry, what was your question? That is only in specific, very specific cases. Let's say you're doing big TCP. Then you'll have to rebuild the kernel in very specific scenarios when you are running on a particular distro type. Otherwise, no. There's no way we ask anybody to rebuild the kernel or nothing like that. That too, we've now accommodated it within the package that we are sending out. I think that was just one-off cases for TCP 6 and for 4, but now I think we've compiled that as well, starting version 1.14.4. So you might have had to rebuild the kernel. Now it's changed completely. Now I'm actually actively working on something with Azure for AFXDP, and there is nothing in terms of compilation of kernel or anything. Yeah, that's all I had.
So I think we have come to the end of today's session. Thanks a lot. Thanks to one and all for making this workshop really a success. When I was telling, when me and Pritham first discussed, we didn't expect, as he was telling, we were expecting like 40, 50 people would turn up.